Hi, my name is Jonathan Dodge, Principal Applications Engineer at United Silicon Carbide, and in this video I'll be talking about the ANPC Active Neutral Point Clamp 3-level inverter topology. This topology is new to FET-Jet Calculator in revision 2. You can find it under AC/DC and then just click on the ANPC tile. So let's take a look at ANPC. So in the ANPC inverter, you can see in one phase like we have 6 FETs. So this creates a number of degrees of freedom for controlling an ANPC inverter. So let's talk about that a little bit. You'll see in the circuit diagram there are colored squares for each FET. Those colors correspond to the colors in the power loss on the right, and also to the control chart on the left. Now, in ANPC, we have both a PWM strategy and a modulation to choose from. So this is the only topology that has both a PWM strategy and modulation selections. For PWM strategy, we have 3. We have low frequency, middle, and by middle we mean Q2 and Q3, so it's the middle of the string of 4 in series. Low frequency middle, where those switch at line frequency, and then the others alternate switching at high frequency or line frequency during half the line cycle. This is useful for situations where you want your short commutation loop, which would be Q1 and Q5 or Q4 and Q6. You only want the short commutation loop switching at your switching frequency, and then the clamps Q2 and Q3 line frequency. High frequency middle is just the other way around. Only the middle 2 switch at the switching frequency and all the others switch at the line frequency. So the idea behind this one is that you can use a high performance FET like silicon carbide for Q2 and Q3 and an IGBT for all the others. However, if high performance is your goal, you'll find that silicon carbide, even in these line frequency switching positions, it outperforms because silicon carbide eliminates the knee voltage both in forward and reverse current directions that you have with an IGBT. Okay, and then finally we have maximum on time, and this is what I like to call it because it's a simple way of describing it. This is based on work by Yang Zhao and Fred Lee at Virginia Tech. Basically, instead of having only 2 FETs turned on out of these block of 4 FETs, Q2, 3, 5, and 6, the other PWM strategies, 2 of those are turned on at a time, but with this maximum on, all 4 of these are turned on during the O state or the clamp state, and so that reduces the conduction loss without really increasing the switching loss, so you may find that to be more efficient. Okay, so that covers the PWM strategies, and then there are the 3 modulation strategies. These are the same as with the other inverters. So we have sine triangle, and you can see what is meant by that by looking at the control chart here on the left. We have space vector, and we have the discontinuous PWM where the FET is either turned on or kept off for 60 degrees out of the 360 degree line cycle, with the on or off time centered at the peak and trough of the fundamental waveform. Okay, so that covers it for ANPC, at least what the selections are in FET-Jet Calculator. Hopefully that is useful to you. Appreciate any feedback. Thanks for watching.